Hello, I'm here to talk about Hardy-Weinberg equilibrium and selection. For my example, I'll be using butterflies. These butterflies are a special kind that comes out three colors: black, white, or checkered black. The colors of these butterflies allow them to hide and camouflage themselves throughout their environment from predators, such as birds, lizards, or frogs. There are currently 200 of these butterflies. 44 are black, 104 are checkered, and 52 are white. So using the chi-square test, I was able to confirm that this population is indeed within the Hardy-Weinberg equilibrium. Here are the frequencies of the alleles. This is the chance of the butterfly inheriting one of these alleles. So now back to the butterflies. A nearby town decides to build a factory. This factory is releasing soot into the air. If you don't know, soot is a very thin black particle that comes from incomplete combustion of coal or wood. You may have seen this before, like with kerosene heaters or something like that, where there's like a black, or like on candles, like that black stuff that gets all around the edge of candles. So the soot goes out and covers the trees and nearby environment. While this may be beneficial for the black butterflies and partly for the checkered one, white butterflies will find it very hard to hide from their predators within this environment. It is not easy for birds and other predators to spot them against the black soot. This will cause a change in their fitness and violate Hardy-Weinberg equilibrium by having a selection. The fitness or the chance of survival to reproduce has now changed. As you can now see, there's now a slight pull towards black butterflies. Having a B allele is now more advantageous than having an A allele. We call this kind of selection directional, where one allele is more favorable over another inside a population. If this was continuing indefinitely, meaning continuously soot covering the trees and the butterflies are still breeding, we expect the A allele to eventually be bred out of this population. Alright, well, I hope that was helpful, and thank you for listening.